Here is question number 1. And these are randomized too, by the way. So question number 1 is this. It's multiple select. And it is, what are used in a TCP three-way handshake? And there's 2 correct answers on the board. Good luck, everybody. A TCP three-way handshake. The meat and potatoes of a reliable layer 4 protocol, TCP. The magic of that is that before it kicks off and you just start sending data, it's going to do a formal three-way handshake with the other device. And once they have the three-way handshake established, they can get to business. Like, is it Telnet? Is it SSH? Is it HTTP? Is it HTTPS? If we have a client like Bob, as I say with a little bit of a smile there, if we have a client like Bob who is connecting over a network, I'll just put a cloud here. Sometimes we draw a cloud just to represent a bunch of connectivity without having to say all the details. And then there's a server here, and it could be a HTTP server, well-known port of 80. So before it starts making HTTP requests, there's going to be an initial connection from Bob's computer. So Bob is going to take a look at his own computer and say, what open ports do I have? And like there's millions of open ports that Bob's computer is using. So let's say he picks 33429, and he'll send with a source layer TCP port of 33429, whatever he chose to use. That'll be the source, and the destination will be the well-known port of the service we're trying to reach. In this case, the browser is trying to reach HTTP, which would be TCP port 80. All right, super. So he sends over that. That's what it looks like. And in the TCP header, there'd be flags. And the flag that'd be set would be a SYN, a synchronization request, saying, hey, I would like to talk to you. And if the server's open for that, the server can send back an acknowledgement. And the acknowledgement is going to come from source port 80. Am I writing on myself? Yeah, a little bit. Source port of 80, and going back to the Bob's port of 33. I'll just put an arrow there. Back to 33429. And in the header, the TCP header, it's going to have an acknowledgement, meaning, yep, great. I got your SYN request. I'll track that. No worries. And it also sends its own synchronization request. So that's why they call that second packet a SYNAC, although alphabetically and logically, it would be called an ACSYN, but nobody calls it that. Because in that one packet, it's including the synchronization request and the acknowledgement at the same time. So it's the acknowledgement to the synchronization that it got from the client, and also its own SYN request that it wants to do to sync up with Bob. It's a two-way street, this whole synchronized or reliable transport protocol. And then finally, Bob will follow up with a third packet in the three-way handshake, which is an ACK. If they're doing HTTP, they would further negotiate and then set up their session. If it's HTTPS, oh my gosh, it's a party going on. With HTTPS, they're going to enable a shared secret key that they can use for encryption, using public-private key encryption for setting up that session key, and then they're going to use that session key. But I digress. Oh no, I don't digress. I go too deep. So the answer to this, there's two acknowledgements, if you count them, right here. There's 1 and 2, and there's 2 synchronization requests, 1, and 2. So it's 2 of each. It's a two-way street. What layer 4 protocols does DHCP use? Here's the good news. Everything that we're learning in CCNA, we can apply elsewhere. In fact, someone once told me, I had a goal when I was earlier in my career to work with certain people in the industry, and I had all those opportunities. It's been great. And that person told me at the time, they said, once you learn a technology like firewalls or a protocol stack or whatever it is, you can take those concepts and apply them to not just one vendor, but to other vendors. And so the things that we're learning in Cisco CCNA regarding protocol stacks and switching and routing protocols and so forth, all that information applies. Also, I want to tell you about my sweatshirt this morning. Let me bring it full screen for this. And let me get you on that camera. There we go. So you might say, Keith, what the heck does a sweatshirt have to do with CCNA? So I'm 56 as of this recording, and I was doing a little cardio just to remind my heart, to keep healthy. And it was like 15 minutes in, so I was taking off my sweatshirt, and I was aiming for this a pole that I was trying to throw the jacket onto, the sweatshirt. So I imagined in my mind the result of that sweatshirt, landing on that hook and just, being correctly landed. And so I saw it in my mind. I took the sweatshirt off. I tossed it and it failed. It didn't make it. I missed it totally. And the moral of this story is just get up and do it again. And that's what I did. I thought, that's a good lesson for life. It's like, hey, I missed my mark. Even though I visualized it, it didn't happen. So I hopped off the treadmill. I have like 10 seconds. It's not plugged in, so it just generates power by turning it. And so I have like 10 seconds before it loses my information for that current session. So I hopped off, grabbed the sweatshirt, got back on, got the elliptical going, and then I tossed that sweatshirt again and got it. So the moral of the story is you can visualize and have goals, and those are great, and we should. And we can, reach towards those goals. And then if something gets in the way, or we get distracted by life or anything in our world, just get up. Get up again. And if you fail then, get up again. If you fail again, get up again. I was talking to, I want to thank Dave, by the way, for doing a proof of this quiz this morning with me before this went live, just to do a proofing. We made some changes based on his feedback. So Dave, thank you for that. And something that I haven't told, I think I mentioned it maybe in a podcast with The Art of Network Engineering, but in 2009, I lost everything. Now, as of this recording, it's 2021. Thank goodness. But in 2009, I lost everything. So a net worth is when you take all the debt that you have and all the assets you have, and then that's your net worth when you balance that all out. And my net worth was zero. It was negative. I owed money. And this is a grown man who'd been working my whole life as a CCIE, double CCIE. And I just had to basically get up in 2009 again and pretty much start from scratch. So I have a lot of benefits in my life. I do. I'm very lucky, But the point is that no matter what happens, we can make changes in the direction we want to go and then just keep on going. And if we fall down or if life gets in the way or something else, just get back up. All right. Dad, are you done? Not yet. Get back up. You can do it. I've got 7 kids. I love all those kids. We've got like 6,000 or 7,000 people in the Discord server. And I've got like 120,000 people who have subscribed over time to my YouTube channel. I care about every single person. I do. And I want to make a difference. So if I can make a difference in yours, let me know. The most valuable resource that we have is our time. And people say, well, if I want to start studying CCNA, what do I do? And the first step, and if you haven't done this yet, I'd like you to commit to doing it this week, is download the exam topics from Cisco. Go to the source, download the exam topics so you know what you're dealing with, then get some study material, and then just plot along, scheduling your time, and just go at it. You can do this. I am the most unlikely person to be in IT. I'm just, if somebody told me like in the 80s I'd be a CCIA didn't exist in the 80s. So if somebody told me in the 90s that I'd be a CCIA and I'd be able to, master some of this content, I'd like, I don't think so. I remember my first CCIE exposure was a quiz question. I was teaching in Jacksonville, Florida. I think I was teaching Microsoft or something for a small company, in-house training. And I saw a news article. It was in print at that time. And it was about sample questions for a CCIE. And I read it. I thought, I have no idea what any of that is. And but then I compare myself to now. I think, what happened? What happened? And the answer is, I just took little steps consistently over time. And it's amazing what can get done. Okay, off of my soapbox, back to full screen. Next, we are now on question number 3. And here we go. I believe in you, by the way. The world is a tough, hard, difficult place. And we come from different backgrounds. It's never easy. However, everybody can make improvements if they just stay on target and they just continue to work. Here is question number 3. It's multiple select. Comparing TCP to UDP, which of the following are true? I'm looking for 2 answers. All right. Romans was asking, did I get my CCIE, the first one, the first time? The answer is I did. And it was because of 8 months of studying, about 4 hours a day, 4 or 5 times a week, just for the CCIE, just labbing stuff up over and over again. And then when I got my second CCIE back in 2003, I got my first one in 2001, I didn't. It took me 3 tries. That's because I went in with the wrong attitude. That was me. I was like, I'm a CCIE, I can just take this exam. Nope. Nope. You gotta, every CCNA you have to practice like it's your first. That's why I use a motto these days, like practice like you've never won and perform like you've never lost. And just keep on getting up. All right, so comparing TCP to UDP, which of the following are true? UDP is not reliable. That's because it doesn't have three-way handshakes, doesn't do acknowledgments, and TCP and UDP both include checksums. If you look at the header of a UDP packet, for the individual segment of data, there is a checksum field that can be used to validate data integrity for that package of data. From this request, what would the server response be? So if Bob is, let's say, mention Bob is making this request. So Bob, when he sends this out, the source port is 34,622. His computer in the background said, this is an open port, it's not being used, it's higher than 1,024, I'll just use it for this session. And it sent out a TCP SYN request over to the server. In fact, we can just verify that. Oh, look, you know what? This is not the initial three-way handshake because we have HTTP in the payload, which wouldn't be there yet if we were on the initial three-way handshake. And we also have some push and acknowledgement. So the initial one will be a SYN request, then a SYN-ACK, then the final acknowledgement. So for this packet, though, it's sourced from 34.622 going to the server. And when the server responds, it's going to be sourced from port 80 going to that port that Bob made the request from. So it's just basically flipped. Now, why is that important? It's important to understand how the protocol works, but it's also important for access controls and filtering and so forth if we want to filter certain types of traffic. So great job to everybody who knocked that out of the park. And let's take a look at who is in the winner's place at the moment. Magic Bunny, 8,213 points. Nice work. Followed by Mystery Lark, Dandy Falcon, Lovely Finch, and Bold Unicorn. All right. Whose layer 4 protocol is being used in this packet? All right, indeed that is IPsec. So the benefit of IPsec is that it's protecting individual IP packets as they course through a network. So a lot of times we'll have sites like Site 1 and Site 2, and then we have a cloud in the middle, like the internet. And then we'll have VPN gateways at each end. Maybe this is device A and this is device B, and they'll build an IPsec tunnel between them. So you might have like the 10.1 network over here on the right and the 10.2 network over here on the, 10.1 on the left and 10.2 on the right. I need to work on my left hand, right hand. I need to watch Sesame Street again, maybe. So with IPsec, these routers can be trained as peers, and they can build an IPsec tunnel. And what happens is each packet, as it reaches the router, it can route it over the tunnel, over to the peer. So what the internet would see, they would see a packet that was sourced from, I'll call it X, and going to point Y. But at layer 4, it would have protocol, where is it? Protocol 50, right there, which is encapsulating security payload, part of IPsec. And they wouldn't know about the payload. The application layer stuff would all be encrypted. So it could be ping requests going from Site 1 to Site 2, or it could be it could be HTTP traffic or anything else for that matter. But the internet over this untrusted network would not be able to see it. All they would see is traffic from this router interface to this router interface with this header at layer 4, and then the payload would all be encrypted. That's one of the beautiful things about IPsec, is that it can help implement our confidentiality and our data integrity as well. Okay, let's move on. We have question 6 of 11. Multiple select. Which of the following are true regarding Telnet and SSH at layer 4? Go ahead and choose 2. All right, taking a look at our answers here. Which of the following are true regarding Telnet and SSH? So SSH does indeed use TCP at layer 4 with the well-known port for SSH as port 22. And Telnet, its insecure little predecessor, is TCP port 23. I don't know if they're predecessors. Actually, they were probably both developed at the same time, but with the TCP/IP protocol stack. But Telnet is clear text, and that would be a great reason if we had to use Telnet for some reason. That'd be a great reason why we would use a VPN tunnel to go ahead and protect that traffic as it goes through the tunnel. So it gets encrypted, shipped over to the peer, then decrypted. a question earlier was asking about, won't it be GRE over IPsec if we have a site-to-site tunnel? And it depends how it's implemented. If we have two sites, let's call this router 1 and router 2, and they've got a cloud between them, and they're peers, we could just use traditional methods like crypto maps, which just take each packet, encrypt it, and then ship it to the peer. Or we could use a GRE tunnel, and then we could protect that GRE tunnel with an IPsec profile, which in effect is going to look like IPsec. So from the outside world, they would not know whether we're using GRE inside or not, because at that point we'd have encrypted traffic. So the internet, whether we're using GRE with IPsec protecting the GRE traffic or just native IPsec between the two, the world who's eavesdropping on this traffic over the tunnel would not know the difference. But great question. All right, moving forward. Here we go, onward and upward. Question 7 of 11. Oh my gosh, so good to have you here today. What is true regarding Radius versus Cisco's TACAX Plus? And that is how you pronounce that, by the way. TACAX. All right. Let's take a look at this. One of the benefits of using a centralized AAA server, I'll put AAA here, which is an acronym from a networking perspective for authentication. The second A is authorization. And the third A is accounting. I've also heard a lot of people talk about like auditing, but tracking. So that's what the AAA stands for. And one of the benefits of using a centralized AAA server is that we may have Bob, who wants to access the network, and maybe he's coming in, and he has different ways of coming into our network. He can come in through a network access server, through a VPN, maybe, or maybe he's coming through a firewall, and hopefully he's also using a VPN, and also possibly maybe a dedicated I'm going way back now, public switch telephone network like with ISDN or something. Maybe he's coming in that way. Or maybe he's accessing multiple different devices. Instead of having Bob's username and password on device 1, 2, and 3, what we could do is have a centralized AAA server right here, and it could have Bob's username and his password and other details about Bob and where he's allowed to access and so forth. And then we simply train our devices, including the NAS device, which stands for Network Access Server, the firewall, and the public switch telephone network device, which should also be a NAS. We train them all to check with the AAA server before when Bob needs to authenticate. And that way we can just keep Bob's credentials here on the AAA server. Now, for the communication between these devices and the AAA server, if we're authenticating an end user, it's very likely going to be Radius, which does use UDP at layer 4, and it's mostly plain text. However, it does encrypt the password for Bob. So Bob's actual password is not sent plain text over the wire with Radius, which is good. But the protocol uses UDP. And the other option is if we have admins. Let me take Kelvin. So let's imagine Kelvin is an administrator, and he's got lots of network devices. He's got a router, he's got a switch, he's got a firewall, and he needs to manage all those devices. Once again, instead as an admin, instead of creating user accounts locally on R1 and the switch and the firewall and all other thousands of devices, we could train all these devices to talk to a AAA server. And in the case of individual command authorization and better, detailed control of what Kelvin's able to do, we could use, instead on the AAA server, we would very likely use TACAX as the protocol. So your server would support TACAX Plus, and the networking devices would support TACAX Plus. Then when Kelvin authenticates using TACAX Plus, these devices would check with that server to verify what Kelvin can or can't do. And it does it for every command. You can set up every command. So if Kelvin's typing in config T, the router can go back to the AAA server saying, hey, he's typing in config T. Is that allowed? For Kelvin? Yes, absolutely. And the response comes back and he gets in. So for authenticating end users, traditionally, Radius is going to be used. It's also open source protocol, or it's open. It's not proprietary. And then for administering networking devices, specifically and most likely in a Cisco-centric environment, we're going to be using TACAX Plus for the administration aspect. But in either case, TACAX Plus uses TCP, and it is fully encrypted, meaning the entire TCP session between the AAA server and these networking devices using TACAX is encrypted. All right, so those are some benefits and pros and cons regarding radius and TACX. Here's our next question, question 8 of 11. NTP, Network Time Protocol. Traffic is going over an Ether channel layer 2 trunk. Ooh. What is true? I'm looking for one correct answer here. The faster you answer correctly, the more points you get. NTP traffic, and this is true for NTP traffic, wherever you might find it, uses UDP, and the well-known port is 123. And the more you're familiar and work with the protocols, the more exposure you have to them, the better you're going to get at it. So I appreciate everybody who's here today. We just have a few more to go. Magic Bunny refuses to relent. 13,469 points. I'm so pleased to see that. Dandy Falcon, Wonder Pony, Mystery Lark, and the Cute Falcon with 12,937. Maybe if the Cute Falcon wasn't so cute, it'd be getting more points. No, I'm just teasing. Cute Falcon, you're in the top 5. Way to crush it. All right, everybody, here we go. Question 9 of 11. Multiple select. Which of the following are true regarding FTP and TFTP at layer 4? I'm looking for 2 answers, and it's either FTP or TFTP based on the answers. Nice. FTP uses TCP with a well-known port of 21. That's for the control channel. And TFTP uses UDP, and that's also true. Fantastic. Also, every Saturday at 10 a.m. Pacific time, you can join me for my office hour on Discord, and it's available for free for everyone. So if you have questions about CCNA level topics that you're studying, you want to reinforce something, that's the right place to show up. Now, if you come to office hours, which I invite everybody to do, it's a lot of fun. I usually cover some topic at the beginning for 15 minutes and then open it up to questions. There's a queue, and I just go through the queue. One of the things I want to point out is that before you ask a question about spanning tree, for example, make sure you've studied a little bit about spanning tree, and that way we can make the best use of our time. So if you've studied spanning tree and then like, okay, how does that designated port thing work again, or who gets to be the root, or whatever it is, then we can start to answer and elaborate on those questions to be more effective for you. So I think if you're brand new to a topic, study it first or take a peek at it first, work through it, and then if you have questions, bring them, and then we can get the most of our time. Okay, here we go. On to our next question, which is question number 10. We're almost done. Whose layer 4 protocol is being used in this packet capture from Wireshark? The telltale signs for this are, so this kind of is like layer 2, that's layer 3, the IP, that's the IP header, which is what we're looking at. And in the IP header, the destination is this bad boy right here, 224.0.0.5, which is the multicast address for OSPF. So OSPF, we could assume from that, is protocol 89, which it is, and that is the answer to this question. And let's take a look at how the answers went. Wow, 62 of you nailed it. Awesome. All right, we have one last question. It's a close race. Everybody who's here, I want to thank you for spending some time and effort in showing up for these quizzes and having a good time. I'm certainly happy to host them for us. And let's take a look at our last question. Here it is. Question 11 of 11. Multiple select. Which of the following are true regarding layer 4? There's 2 correct answers on the board that I'm looking for. Good luck, everybody. All right, which of the following are true regarding layer 4? RIP uses UDP, that is true. And I think, let's see, what is the well-known port for that? Is it 520? No, that doesn't seem right. If somebody knows the well-known port or you want to Google it for me, please confirm what the well-known port is for UDP with RIP. And then we'll come back to it. 520 seems like it might be right, but I'm not sure. Okay, BGP uses UDP, or sorry, BGP uses TCP, which is true, and that is like TCP, I think it's 179. I'm going to have you guys check me on all this. And OSPF uses its own layer 4 protocol, and that is 89, as we saw in that previous packet capture, and EIGRP has its own layer 4 protocol, and that is 88. And these, I would say, are not critical to remember the actual well-known ports or the port numbers specifically. but it's just a rehearsal about layer 4. So look at my notes. Oh, good. Thanks, Rob and Andre. And good. This RIP is 520. And how about BGP 179? Okay. Thank you very much for that confirmation. Okay. All right. I think that's question 11 of 11. Let me clear off the screen and thank everybody for their assistance and those confirmations. So let's take a look at the winners table. You're all winners for being here, but the top 3 people are right here. Mystery Lark, you did it! Mystery Lark, you did it! Awesome. With runners up, those 2 down below. Also, I would love to get some feedback from you if I could, and let's do that right now. Here is the you guys did great, guys and gals. We did great. This is the hardest question. Now, sometimes I do these quizzes and there's like 8 hardest questions, but this is the hardest question. What are used in TCP 3-way handshakes? I don't think we'll ever get that wrong anymore, though. 2 SYNs, 2 ACKs. That's it. So it's a 3-way handshake. So it's SYN, SYNAC, ACK. 2 SYNs, 2 ACKs, and we've got it down. Let me get your feedback as well. That helps me out too. Also, for a few moments, if you want to ask any questions directly to me in this live stream, I won't include them in the final, edited version, but I will be more than happy to stick around for a moment and answer a few questions now. But do me a huge favor, start off now with those questions with the @KeithBarker, so it shows up on my screen. I can easily find it, and that way I can answer them. And if there's no questions, that's cool too. But if you have a question or two, also I want to remind you about 10 o'clock on Saturdays on the Discord server is my office hour. So please show up for that. You can ask me questions. We can elaborate on concepts, and it's all related to CCNA. That's the focus there. So if you ask me something outside the scope of CCNA, I may defer to either a private chat or have somebody else in the forum be happy to chat with you about that. But my focus for these social media tools are CCNA related.